Okay, so in previous class we have seen how to construct three address code from a given expression, right? Uh, let's look at this uh, procedure calls, right? Procedure calls are basically, I might have skipped this. So procedures calls are basically like your function calls. Okay, so if you have some functions, you having parameters like this. Let's So suppose you have a function some a comma b, right? So suppose you have some function like this. Okay, so suppose you have a function like this and you are calling this function. So what would be the three address code of this function call? So the three address code of this function call will basically be like this. Okay, so let's look at the structure here. So first you need to write what are the parameters. So this a and this b is parameter, right? So you need to write the parameters. So for this function call you need to write the parameters, and after the parameters, as this line is calling the function, so after the parameter you need to use the call keyword and give the function name, which is sum, and you need to write comma, and you need to write the number of parameters. What are the number of parameters? 1 and 2, or you can count it like this: 1, 2. So you write the number of parameters. Okay, is this part clear? How to convert uh, procedures into three address code? Any confusions? Right. So suppose it is assigning a value to it, right? So suppose this has return. Okay. Okay. So suppose this has return, and it is assigning some value to t1. Okay. So this value will be basically saved at some address, right? Or we can say, so suppose this is t45 is equal to this. Okay. So we just going to say t1 is equal to t45. Okay, is it clear? Or this might have locations. Okay, so Okay, so this might have location 100, 101. This might have location 102. This might have location 103. Right. So these are the locations of this 300 code instruction. So at location location 104, we can say that we are saving it to variable t1, right? So t1 is equal to 103. So whatever the value is not call. So it was call, right? Okay. So whatever the value was saved at 103, this value is being assigned to t1. Okay. So either way is fine. Any questions? Okay. So let's move. Volume. Yes. Okay, you can watch the recording later. Okay, so in previous class we have seen this already, right? But we have skipped the representations of three address code. So these three address codes are basically represented as a record. Okay, the record of four fields, which is quadruples, a record of three fields, which is triples, two records of one field and three field, which is known as indirect triples. Okay, so basically we use these records to symbolize these three address codes or to represent these three address code, right? Because computer cannot work with strings, right? They need some kind of data structure to actually represent something. So we use records for these three address code. Okay, now let's look what are quadruples, triples, and indirect triples. Okay, so let's see. So we'll consider this three address code. Okay, so suppose you have some expression, and from that expression you have converted this three address code. Okay, now we need to represent it as quadruples, triples, or indirect triples. Okay, so this is your code. So as the name suggests, quadruples is basically a record with four fields, right? Each each instructions will represent uh, one instance of the record. Okay, so suppose we have t1 is equal to minus, or you can have u minus. So this minus is basically this minus c, or you can call it as unary minus, u minus. Okay, so both is correct. So basically, what are the four fields of this record? One is an operator. Okay, one is an argument, another one is an argument. So these arguments are basically operands of your operator. Suppose this is the plus operator. Your plus operator will have two operands, one at the left and one at the right. Suppose a plus b, or a plus 10, right? Or 10 plus 20. So these are your operands. So these arguments are basically your operands of your operator. Okay, and what is the fourth field? The fourth field is the result. Wherever the value is being stored is known as the result field. Okay, so suppose you have a record, and inside your record you have four fields. One is operator, one is argument one is argument two, and one is result, right? So you need to represent this instruction inside this field. So how are we going to do that? Let's look at it. Okay, so first instruction is T1 is equal to minus C. So this minus is basically our operator. So under operator we need to write minus. Okay, and we this is basically a unary minus, meaning we only have one operand. What is the operand or the argument? The operand or the argument is C. So under argument 1 we write C. We do not have any other arguments, so we keep this empty. Now we are saving this result. We are saving this result at T1, right? So the value will basically be, the result field will basically be T1. Okay. So this is being, this record, suppose this record is being saved as memory location 1. Okay. Sorry, 0. Now for the next instruction. What is the next instruction? The next instruction is T2 is equal to B plus T, B multiplied by T. Okay. So again we have four field. So for what is the operator? Our operator is basically multiplication sign, right? So inside our operator we need to write multiplication sign. And what are the arguments or what are the operands? So B and T1 are basically are our argument. So argument 1 is B, argument 1 is T1, right? And the result is stored at T2, right? So the result is basically in T2. Similarly, as T1, we write T3. So operator is minus. We have one argument which is C, and the result is saved under T3. Right. Now the fourth instruction says T4 is equal to B into T3. Right? So under operator we have multiplication. One argument is B, another argument is T3. Now where the result is being saved? The result is being saved as T4. So we write T4 under result. What is the next instruction? The next instruction says T5 is equal to T2 plus T4. So we have a plus operator, right? And what are the operands or two arguments? T2 and T4. So under argument 1 we write T2, and under argument 2 we write T4. And where is the result being saved? The result is being saved at T5. Okay. Now let's look at the final instruction. It says A is equal to T5. So what is the operator in this case? The operator in this case is basically the assignment operator. So we write the assignment operator. If we do not have any other operators, we just write the assignment operator, and the value of T5 is being copied to T1. So what is the operand? The operand is T5, and the result is being saved at A, right? So argument 1 has T5 and the result has A. So this is basically the quadruples representation of this. Okay. Any questions? So once you have the quadruple representation, you can easily convert it into a triples representation. How? So you just remove this result part. Okay. So you just remove this result part. So you're left with three fields. One is an operator, one is an argument, one is an argument two. Right. So whatever result you had is being saved at those memory locations. Memory location 0, 1, 2, 3, 4, and 5. Right. So whatever the result of this operation minus C is being saved as the memory location 0. Instead of T1, it is being saved at the memory location 0, right? So when you are going, wherever you are using T1 in the argument field, instead of T1 you are going to use 0, the memory location 0. Okay. Similarly, wherever you are using T3 or T4 or T5, wherever those T1, T2, or T4 was saved at. So T1 is basically saved here, right? This is T1. So T2 is saved here. T3 is saved here. T4 is saved here. T5 is saved here. And T6 is saved here, right? So wherever those temporary variables were saved, instead you are just going to use their locations. Okay, so in quadruple representation you're just going to use their locations, right? So if you look, what was the first instruction? The first instruction is minus c. So our operator is minus, and our argument is c. And where is it being saved? Is it being saved at t1, or in our case in our zeroth location, right? So whenever we need to use minus c, we're going to use 0 instead of minus c. Okay, so in our next instruction is basically b into t1. What is t1? T1 is basically the instruction saved as at zeroth location, right? So we use b under the argument, we use b, and instead of t1 we use 0 memory location. Okay, so the next instruction is t3 is equal to minus c. So again we write minus c and we save it under the memory location 2, right? So this is t3, right? Whenever we are going to use t3 in the next instruction, look, we are going to use t3. So instead of t3 we are going to use the memory location 2. So we are going to use the memory location 2, and this is your memory location t4, right? So whenever we use t4 here in the next instruction, we are using t2 and t4. So instead of using t2 and t4, we are going to use the memory location 1 and 3. Okay, so this is basically your quadruples and triples representation. So one more representation is basically your indirect triples representation. Okay. হ্যাঁ বলেন। এটা তো আর্গুমেন্ট, আপনার দুইটা আর্গুমেন্ট না। অ্যাসাইন অপারেটরের আর্গুমেন্ট, আপনি যদি এইভাবে চিন্তা করেন, ইউ ক্যান ট্রিট ইট অ্যাজ অ্যান আর্গুমেন্ট। আপনি যখন ট্রিপলস নিয়ে কাজ করতেছেন, ইউ ক্যান ট্রিট বোথ এ অ্যান্ড টি ফাইভ অ্যাজ আর্গুমেন্টস, কারণ অ্যাসাইন্ড অপারেটরের দুই দুই সাইডে দুই অপারেন্ট আছে, থাকে রাইট? এক অপারেন্ট থেকে আরেক অপারেন্টে ভ্যালু কপি হইতেছে, ইউ ক্যান কনসিডার ইট অ্যাজ অপারেন্ট অ্যাজ ওয়েল, রাইট? সো এখানেও আপনি হচ্ছে চাইলে এই কোয়াড্রুপলসে যখন করতেছিলেন, এখানে হচ্ছে আপনি অপারেন্ট হিসাবে সেভ করে রাখতে পারতেন আর্গুমেন্ট হিসাবে, এবং রেজাল্টও হচ্ছে আপনি গিয়ে রাখতে পারতেন। কথা বুঝতে পারছি? আচ্ছা, সো আমরা ট্রিপলস নিয়ে কথা বল, ইনডাইরেক্ট ট্রিপলস নিয়ে এখন কথা বলি। So just like triples, you can also have your indirect triples. So indirect triples, say you have your triples, okay? So this is your triples from this equation, this triples, and you have another record having these memory locations. Look, you have this memory references, right? So these are memory references 0, 1, 2, 3, meaning at 0 location something is being saved, and you write the actual physical address of that 0 location. 0 is a logical location, right? So you know the difference between the logical location and physical location, hopefully. Okay, so this is your logical location, and what is the actual physical location of this logical location? You write those beside it. So you have one record consisting of this, and you have one record consisting of this, right? So this is basically your indirect triples. Okay, any confusion how you can represent quadruple triples and indirect triples? Any questions from this? Okay, So let's start our final topic. Okay. Now we're going to see how you can use this grammar. So you have a grammar here, how you can use this grammar to construct a three address code from a given array instruction. Right? So suppose you have this array instruction C plus A I J, right? You have this instruction, and using this instruction you can construct this three address code with the help of this production rule and semantic actions, right? But the thing is, this semantic rule and semantic action considers that the array is being saved in your memory location as a row major. Okay, it is being saved in your memory location as a row major, right? So what do I mean by that? So think of this as your memory location, right? So your memory locations are basically one dimensional data, right? You can only store them in one dimension. But suppose you have a two-dimensional array, right? Sorry, you have a two-dimensional array with three columns and two rows, right? Or suppose four columns and two rows, right? That is possible. Okay. Okay. Can someone tell me uh, how you can store a two-dimensional array data into a one-dimensional memory location? কিভাবে আমাকে একটু বুঝায় বলেন how I can store this data. Okay, so suppose 1 2 3 4 5 6 7 8, right? So this is your row 1, this is your row 2, so this is your column 1 and column 4, right? And so you're saying you write 1 here and 2 here. But how you know, J? But when you are accessing some element, suppose you are accessing array of uh, first row. So suppose this is one index based array, right? So first row and third column, right? So this is your first row, and this is your third column, which is three. So how you are going to find this inside your memory location? So you are writing all the rows first in your memory location, right? One, two, three, four, 5, 6, 7, and 8, right? Yes or no? Right. So you are writing all the rows first in your memory location. But can you also do this? So suppose you have another memory. Can you also do this? You write all the column first, 1, 5, then 2, 6, then 3, 7, then 4, 8. Is this also possible? Instead of writing the rows, we are writing the columns. Is this possible or not? Okay, so this is basically known as row major, right? So this is basically row measure because we are saving the values of rows first. Then we're moving to the next row. Okay. So we're saving 1, 2, 3, 4 to serially the value of rows serially. Then we're moving to the second row, which is 5, 6, 7. Okay. But if we put the values like this 1, 5, 2, 6, 3, 7, 4, 8, meaning we are putting the values of a column first, then we are moving to the next column, right? So this is row measure. So this is row measure, this is row measure, and this is column measure, right? So there are two ways to represent array inside your memory. Now, so the grammar we are using is for calculating the values of an array that is being stored in a memory using the row measure rule. Okay, is everyone clear on this? Okay, now the question still remains. Okay, so if you do this, suppose array of 1, 3, how are we going to find the value of this index? Right, for that we have rules. So here you can just read about this part if you want. Okay, so it basically says if it is a one dimensional array. Okay, so if it is a one dimensional array, how can we find the index with n elements? Okay, if your index is zero base, right? So your index number starts from zero. So we have a base location and I is your index and we have a, okay. So let's look at this. Int I have declared a array of integer that has three elements, right? So this is one dimensional array. It has three elements. So if we draw the array, okay, so this is index number 0, this is index number 1, and this is index number 2, right? And if we put values here 1, 5, and 8, okay. So suppose we are accessing the index 1, okay. So we are accessing index 1. So this array starts at a base location, suppose 100, okay, 100. So which memory location does 5 start from? Can anyone tell me? No. Anyone else? Okay, what is the size of how many bytes does each integer value needs to being stored inside your memory? So it needs 4 bytes of space. So this one needs 4 bytes of space. So including 100 and 101, 102, and 103. So these are basically your 4 bytes that this one occupies. Okay. So your next index start from which memory location? 104. What about this one? This one starts from 108. Is this part clear to everyone? Yes or no? So if you want to find what is the memory location of index 2, what you need to do, you need to add with your base how many values you need to add. What is the index? The value of the index is 2, and what is the width? The width of the data type is 4. If it was float, you need to multiply by 8. So if you do this, what will be the value? 100 plus 8, which is 108. If you see, the value of 2 starts from 108. So this is basically your base. This is the index number, and this is the width. Okay. So this is the width. So this is the formulation for one dimensional array. Okay. And this is the formulation for row major array. Okay. So this is the formulation for row major array. Okay. So similarly, we have the formulation for two dimensional. We have the formulation for a k dimensional. Okay. And you can rewrite this as this by doing some math calculations. You can rewrite it as this. For k dimensionals, you can rewrite it as this. Okay. So you can read this part if you want. Or suppose now your array does not start from the location 0, right? Your array's index does not start from location 0. So suppose you have an array and your index starts from, so this is your new index. Your index starts from 5, 4, right? So this is your index 4, this is index 5, and this is index 6. So in that case, you can calculate the address with the help of this formulation. This formulation says base plus I is your index, minus low. This low is the lowest number of index, the first index. What is the lowest number of index? This 4 here, right? So this 4 into W. So W is your width. Okay. And here it talks about the row measure and the column measure. Okay. Okay. So before we dive into the SDT part, do you have any questions regarding this? Any questions? Okay. So from your report, this is one part of the three address code generation, right? So the array one. So this is the array one. And if you see here, please note this down. In the next class, I will show about the boolean and the looping SDT for three address code generation. Okay, but note down these pages. Okay, so 401, page 401, you can see the grammar for flow control statement. So this is the grammar for if else. Okay, so this is the grammar for if else. Okay, and here is the corresponding SDT. Okay, so if else, so if else. Okay, so here these two are the corresponding SDT. Okay, and similarly you have while. So similarly you have while. So this is the instruction for the while. Okay, so here is the block diagram of how these are executed. Okay, so how if are executed, how else is executed. This is basically the flow control, where your code moves from one instruction to another. Okay, so you must have idea about this from your 341 course, right? So in your 341 course, you were taught that while using if and else, how does the flow control of this statement occurs, right? Similarly for while. So when you did for loop and while loop in assembly programming, you have seen how the flow control works. Okay, So this is basically a diagram for your flow control. So that is the part you need for your report. And with the branching and loop, you also need some array declarations, right? So for array declarations, we have this graph. Okay, so we have this graph. So sometimes you basically need to combine this grammar with the grammar I just showed you. Okay, so you combine these two grammars and make one big grammar, and also this grammar. Okay, for expressions you need to use this grammar. Okay, so this is the grammar for generating three address code of expressions. Okay, so this is also included in the array of your grammar. Okay, again, this basically, this pipe sign basically means concatenation, not or sign. Okay, so these are concatenating your codes, meaning writing your three address code one line after another. Okay, so let's get started. uh, can anyone explain how many dimensional array can I declare with this method? একটু ভালো করে দেখেন, একটু ভালো করে দেখেন ওই যে অ্যারের যেই এসডিটিটা দেখছিলেন না, যে অ্যারে ডিক্লেয়ার করার, কাইন্ড ওর মতো না? Right, right. So how can you say this, if this SDT can give multiple dimensional array using which rule? L produces L1 bracket E bracket, right? Using, by seeing this rule, you can see that this L can produce ID, right? So L can produce IDE. What does this mean? So L can produce IDE, right? That means this ID is basically going to be an identifier, which is any variable name. Then what is this E? This E is basically an expression, right? So this E can be any expression. So expression as in, it can be A plus, it can be I plus J plus K, or I plus uh, J minus K into P, right? Right. So this can be a expression, but in this SDT you are only given the expression can have only plus operator, right? So the expression can only be in form of summations. That's it. But if you decided to add other rules such as E minus E, E into E, E divided by E, we will also add the corresponding rules here. Okay. So can can someone tell me if this is a valid expression of an array index? Is it a valid expression of an array index? Why not? According to this grammar, not. But suppose this, right? Is this a valid expression? So suppose these are basically your index, right? Whatever the expression, the value of this expression will be, suppose this calculates into 20. So we are accessing the 20th index of this array. Okay. Is everyone clear about this? Yes or no? Okay. So this can produce this rule as well as this rule. So or this rule. What is this rule? L1 bracket E. What does this mean? So it can produce either ID this, or it can produce or it can produce L E, right? So suppose now I want to declare two-dimensional array. So how we are going to do that? First, we will use this L E, right? So this L will again be constructed into this grammar, right? So L produces ID. So this L will be ID E, and from we need still need to add this E, right? Okay. So that's how we make two-dimensional array. Now suppose we want to make, so basically this ID will be your A. Suppose this is I. So suppose this is J, right? So the expression is I, the expression is J. Now suppose we want to make three-dimensional array. How can we do that? So we use this L to again produce this row. So this L will produce L E. Okay. Now we can use this L to again produce this row. So this L will produce ID E. So this E can produce I, this E can produce J, this E can produce K, and this ID can be suppose A, right? Or this expression can produce uh, A plus B, X plus Y, M plus N, because that is valid, right? So this expression is also valid. So and this, suppose this will produce T. Okay. So this is basically a three-dimensional array. So with the help of this grammar, you can produce multiple dimensional array, right? So what is E? So E is basically, E can produce a expression that is either uh, positive, right, or additional expression, or E can produce an ID, right? So let's look at this one. Wait. Okay, so your E can produce E, another expression plus another expression, or it can produce ID, or it can produce another. Suppose we are using this rule L. Okay, so L L produces ID E, right? So this ID can be A. This E can be two expressions, which is E1 plus E2, right? So this E1 can be A. So this E1 can be X, and this E2 can be Y. Why is that? Because this E can produce ID. So here you can see this E can produce ID. Okay. Or it can produce an array. So this E can produce another L. right? So this E can produce another array, meaning I can have another array here, right? So what does this mean? It means the value of index 10 of B is the new index of this array, meaning whatever value we have at index 10. So suppose this this is your array B, right? So suppose at index 10 we have a value of 2, right? So now we are accessing the array of A and the index value is 2. Okay, so now we are basically accessing array of 2. Okay, so this is basically how you can use this E to add more expression, or you can turn that expression into ID, or you can turn that expression into another array. Now we have our start symbol. The start symbol is basically very simple. The start symbol can be either ID is equal to E or L is equal to E, meaning we're assigning an expression or array index into a variable, or we are assigning a value or expression into an array index. Okay, so with the help of this you can make all sort of array expressions. Okay, now tell me, do you have any questions regarding this? আবার একটু বলবেন, আমি আপনার কথা বুঝি নাই। হ্যাঁ, অবভিয়াসলি ইউ নিড টু পার্স দ্য ট্রি। আমরা তো এখনো ট্রি বানাই নাই। আমরা কোনো এক্সপ্রেশন নিয়ে কি এখনো দেখছি? না, না। সো we need to have a string first, right? So we need to have a string and we need to parse that string. Okay, so now let's look at the example. So আগে আমরা বলি, did you understand the rules of this grammar? We still haven't seen how this SDT works, right? We haven't seen the rules. We have only seen how this grammar works, right? So any question from this grammar? Okay. Okay, now let's look. So here we need to draw a parse tree for this. C plus A of I and J, right? C of A, C plus A of I and J. So here what we need to do is basically draw this parse. So to draw this, we can start from this rule. So you see, this rule is not needed because we're not assigning any value to anyone. Do you see any assignment operator here? There is no assignment operator here, right? So we can start from this rule, right? So this rule says E can produce E plus E, right? So we are starting from this rule. So let's keep keep the rule here. So we are starting from rule. Our task is C plus A of I j. Right? So this is our one. So here we're going to start from E, right? So E will produce E plus E. Okay. Now I need to construct this E into an ID that will give me C, and this E into an L that will give me A of I plus j. So this L will basically give me I L bracket E bracket, and this L will give me ID bracket E bracket, right? And this ID will give me A, this E will give me I, this E will give me J. So if you can see, if we traverse this, C plus A bracket I bracket J. Is everyone clear how we can draw this tree? Yes or no? Okay, so after this, we can, after drawing the parse tree, we can add the semantic actions, right? We can add the sorry, we can add the attributes. So here we have added the all the attributes, right? Now, so basically in your question, it will be said that whenever this new temp is being created, or whenever this instruction is used, new temp instruction is used, it will create a temporary variable named t, right? And inside the temporary variable, it will have a subscript. It can be 1, it can be 2, it can be 3, it can be 4, right? T1, T2, T3, T4, right? So when you first use this instruction, the value of the subscript will be 1, and the next time you use it, the value of the subscript will be 2. Okay. Again, for this instruction, it will be said that now that you are using a new temporary variable, the t is already given, so that is fine. But the subscript will either be, if it is one, it was 1. Now we have made a new temporary, so the subscript will be 2. If it was 2, then it will be 3. If it was 3, then it will be 4, right? Whenever you were using the new temp method, the subscript of the temporary variable will be increased by 1. So are we clear about what this method does? This new temp method, right? So in your 3 address code, you had compiler generated temporary variables, right? So this new temp will create a temporary variable, and it will provide a subscript to that variable. The name of the variable will be t, and it will have a subscript. Depending on how many times you use this method, the number of subscript will vary. Is everyone clear? হয়েছে তো? বাট এখানে তো আমি 3 অ্যাড্রেস কোডটা আমি নেই নাই। মানে আমি যখন ছবিটা ক্রপ করলাম, তখন তো এখানে 3 অ্যাড্রেস কোড ছিল, ওইটাকে আমি নিছি। ওই 3 অ্যাড্রেস কোডে দেখবেন T1, T2, T3 এগুলো আছে, ঠিক আছে? Okay. Now also in the book it is said that the type of this array. So our thing was C plus A of I and A of J, right? So we need to calculate the 3 address code. We know to calculate the 3 address code of an array, we need to multiply what is inside by the width of the value, right? Or the width of the type. So do you see any integer or float type here in this instruction, in this syntax? No, right? So it is given in the book that the type of this array is array of two, array of three integer, meaning this is a two-dimensional array. It has two rows and it has three columns, right? And all these column values are of what type? Integer type. So this type of a is given, right? So that this type of a is already given to you, and it is said that the I is basically an array of three integers. So an array of three integers. So let's see here. uh, Here, so it is said that the type of ai is array of three integers, right? And the width of this a of I is 12, right? This is important. This information is important because we will need it to generate three address code. Okay, and the type is annotated. The type of a of ij is integer. এখানে বলা আছে যে the type of a of ij is basically an integer. Okay, and in the annotated parse tree you are also given that the type of a is array of two, array of three integer, meaning it is a two-dimensional array consisting of two rows and three columns. Okay, so this is the information given. Now how we're going to parse it? So first we use the depth first search method. So we go to this column. Okay, so here e of c, right? So we're adding a new temporary variable. Wait, so e of id, right? So this one. So that means e of address, this address is basically top dot get id dot lexi, meaning what is the identifier? The identifier is basically saved at your symbol table, which is top, right? And the symbol table or hash table name is top. It is saved in the symbol table. You need to get the lexeme of this identifier. What is the lexeme of this identifier? The lexeme of this identifier is c. So what is the address of e? The address of e is basically c, right? Now after this, so this falls under e produces id rule. Now after this we go to this part. This part is already given to us. The type of a is, however a is not here, but the type of a is what? Array of two arrays, right? So before going here we need to look at what is the actual rule of this, right? So this was this rule. L produces, sorry, L produces L1. Oh, my bad. Okay. So this was this rule. ID E bracket E, right? So the ID is A. So there is no rule for ID. So ID dot type bole কোনো rule নাই এখানে. There is no rule saying ID dot type. So this was already given to us. So this rule was already given to us, right? So we are done with this. Now we have a bracket. There is no rule for bracket. We also have e inside, right? So let's look. After going here, we move to this part, no rule. We move to this part, we have a e. Now we have a rule for e. So this e is producing what? This e is producing an id. So now we use this rule. So e dot address is equal to top dot get id dot lex, meaning the address of e will be the name of this identifier, which is I. Okay. So after this we go to this rule. So there is nothing here. Okay. So there is nothing here, and after that we go to this L. Okay. So this L. Now that we are done reducing this. Now we are done parsing id bracket e. This whole thing is being reduced to this l, right? This whole thing is being reduced to this l. And as this production rule is after the, sorry, and as this uh, semantic action is at the end of the production rule, meaning whenever this is being reduced to L, this rule will be applied. Okay, now it is time to apply this rule. So now we are going to apply this rule here. Okay, now let's see what it is doing. So first it has L dot array is equal to top dot get id dot lexi. So what is the value of array? Array, the value of array is whatever the id it has. The id is basically a, so the l dot array basically means a, right? Okay, now what is the l dot type, meaning what is the type of that array? So the type of that array is l dot array dot type dot element, meaning whatever the type of the element it has, array type will be similar. So if you see here, this instruction says the type of this element was integer, right? So type of this, the type of this was array, was type of the array was integer. So the type of this array is basically an integer, but it has a three, it has three more elements, right? So it is basically a integer array of three elements. So this is why we're using the composite array construction. Okay, so after that it says l dot address is equal to new temp. So what I said, whenever you are using this new temp keyword, this new temp method, it will generate a temporary variable t with a subscript. So far we have not used any, so currently our subscript is 1. So see, l dot address is equal to t1. Now comes the interesting part. It says generate, this gen basically means generate. This is to generate a 3 address code. It says generate l dot address is equal to e dot address multiplied by l dot type dot width. Okay, so it says generate l dot address. What is l dot address? L dot address is basically t1. So we generate a 3 address code which is t1. T1 is equal to e dot address. What is e dot address? This e is basically this e, right? So e dot address is I, and what is l dot type dot width? You see, l dot type is array of 3 integers. Okay, and it is given in the book, the array of 3 integer, the width of this is 12. Okay, if the information is not given, you will just simply write w1 or w2 here. But if the information is given, you need to write the proper value. The proper value is 12. So see, this generate method already have generated a 3 address code here. Okay, so this already generate a 3 address code here. So if you look, this 3 address code is the same as this one, t1, right? So that is how we are generating the first 3 address. Now let's keep going. So far we have done this, we have done this. Now we're going to this, right? So this square bracket has nothing, this e has something, right? So now we're going to this part. So this, হ্যাঁ বলেন। না না, এখানে দেখেন কি বলছে, l ডট অ্যারে ডট টাইপ ডট এলিমেন্ট, রাইট? আচ্ছা, আমার কিবোর্ডে ইয়ে হচ্ছে না দাঁড়াও। আচ্ছা, এখন আমাকে বলেন তো এ ডট অ্যারে টাইপটা কি? এ ডট অ্যারে টাইপটা এটা না? এটা কি না? Okay, everyone listen carefully. What is the type of a dot array? So a dot type is array of array of three integers, right? It means a two-dimensional array. Okay. Now it says array l dot array dot type. Okay, so this is our l dot array dot type. So what is the value and what is the element? This is the element, right? This whole thing is the element, and this is the number of element. Yes or no? So what is the element? Array of three integers, right? So বুঝছি এখানে কেন হচ্ছে array of three integers টা আসছে l dot type এ, because a dot type is the whole thing. This is the number of element and this is the element. Okay, anyway, let's move on. So now কোনটা? বুঝ- হ্যাঁ হ্যাঁ, এটা তো বইটা পড়ে দেখেন, ইনস্ট্রাকশন দেওয়া আছে। আপনি একটা র্যান্ডম অ্যারে ধরে নেবেন, রাইট? আপনাকে যদি বলা না থাকে আপনি একটা র্যান্ডম অ্যারে ধরে নেবেন। সো এটা তো টু ডাইমেনশনাল অ্যারে, তাই না? সো এখানে টু আর থ্রি এর জায়গায় যে কোনো নাম্বার দিতে পারতেন আপনি, এবং এখানে যেহেতু টাইপ বলা নাই, এখানে ইন্টিজারের জায়গায় যে কোনো কিছু দিতে পারতেন, ফ্লোট দিতে পারতেন, অন্য কিছু দিতে পারতেন। ওকে, ওয়ান ডাইমেনশনাল হয়তো তাহলে জাস্ট এল ডট টাইপে হচ্ছে জাস্ট ইন্টিজার হইতো। কারণ দেখেন ওয়ান ডাইমেনশনাল যদি হয় এইটুক হবে, তাহলে আপনার টাইপ কি? ইন্টিজার। ওকে, সো অ্যাগেন ইফ দ্য ইনফরমেশন ইজ গিভেন ইউ নিড টু রাইট দ্য ইনফরমেশন প্রপারলি। আপনি যদি ভুল রাখেন ইউ ইউ উইল নট গেট এনি মার্ক। ওকে, সো ইনফরমেশন যদি গিভেন থাকে ইউ নিড টু রাইট দ্য প্রপার ইনফরমেশন, অ্যান্ড ইফ দ্য ইনফরমেশন ইজ নট গিভেন ইউ ক্যান রাইট হোয়াট এভার ইউ ওয়ান্ট, আই ডোন্ট কেয়ার। ওকে, now let's move to the next part. So next part will use this rule. L produces L1, this is L1 and this is bracket E. So this bracket has no rule. This E has a rule. E produces ID. This rule will be applied. So E of address will be J. Okay. E of address will be J. Wait. Okay. So this will be basically J, and after that we need to go to this part. Okay. Now this does not have any rule. Now we go to this L part, meaning we are again at this one, right? But this time L produces this. Okay, so this time this rule will be applied. This time this rule will be applied. Now it says L dot array is equal to L1 dot array. So L1 dot array will be same as L dot array. Okay, and what is the type of L? The type of L is L L dot type. What is the type of L? Array of three integers, right? Array of three integers. So what is the L1 dot type dot element? What is the element? The element is integer. So the type of L is integer. And see, we have this line, T is equal to new temp. So we already had T1 is equal to I into 12, right? Then we have a new temporary variable which is T. So we need to add a subscript to it. So T2 is equal to new temp, right? So the address is basically the T, this is basically T2. Okay, now there is no rule. Now it says L dot address is equal to new temp. So here you can see L dot address is equal to new temp. So we create another T and we give it another name which is T3. So L dot address is equal to T3. Okay, Now we need to implement the remaining rules. So next generation says t is equal to, remember that t is basically t2, t is equal to e dot address. What is e dot address? J into l dot type dot width. So what is l dot type? Is integer. What is the width of the integer? Integer width is 4. Okay. Now it says another, generate another 3 address code, which is l dot address. The l dot address was t3. Now we are going to generate l dot l1 dot address plus t. What is the l1 dot address? L1 dot address is t1. T1 plus, what is t? T is basically t2, right? So t2, t1 plus t2. Okay, so why we are multiplying then adding? Because if you look at this rule, so if it is a two-dimensional array, you need to get the memory address. So what you can do, you can just multiply and then add together, right? So you can multiply and then add together, and l dot array is basically the value of your base. Okay, sorry. Okay, so this is t3. So after this, we're going into, we're done with this, right? So after this, we're done with this. Now, so now we're at the, we also have done this plus, right? So this, this, and now we are going to e producing, let's see, e producing l. So e is producing this l, right? What is the 3 address code for that? E dot address is equal to new temp, then we need to generate. So e dot address is new temp, which is t4, and we need to generate a new 3 address code. So you see t4 here. So new 3 address code is e dot address, which is t4, equal to l dot array dot base. So the base is basically a, right? So base is the array name, right? A bracket l dot address. What is the l dot address? L dot address was 3, t3, t3 bracket. Okay, and now we are finally done with this. Now we go to the last reduction. So e produces e plus e. So again, this will create a new temporary, which is t5, and we need to generate this rule. This rule says t5 is equal to e1 dot address, which is c, and e2 dot address, which is t4, right? So this expression basically generates these 5 lines of 3 address code, right? And through this SDT, we have seen how can we generate this. Okay, any questions? Any questions regarding this? Any questions? অ্যাসাইন করতে হলে উপরের রুলটা ইউজ করতেন। So similarly, you are going to use this rule. Okay, you are going to use this rule to generate 3 address code. So this basically means concatenation. You are adding one rule next line after the new rule. Okay, so this new label means this new labels basically means to create a label for the jumping. Okay, and uh, this code part. Okay, so this code part will basically generate as a b dot code, s dot code, right? So this code part will generate more codes. Okay, the 3 address codes. So in the next class, even though our syllabus is finished, in the next class I will discuss about this. Okay, so it will be better for your uh, assessment part. হ্যাঁ, থার্সডেতে আপনাদের নেক্সট ক্লাস আছে না? রিপোর্ট সাবমিশন তো ফাইনালের আগে। Okay. Do you have any questions from today's class? If not, I'm going to stop the recording.